Hi friends, now we are going to start our discussion with respect to chapter 8, and chapter 8 is time, speed and distance. So here we are going to study about time, the speed and distance. So we will be doing some example questions with respect to this chapter. We will be discussing the theory portions and we will be doing practice questions, and also we will be doing previous questions with respect to this chapter. So this is the next chapter of numerical ability or quantitative ability, and this is chapter 8, time, speed and distance. Now we are moving to its theory portions as an introduction. So as an introduction for time, speed and distance, time, speed and distance are very highly important topics, or this is a very important chapter to understand the logical development and the visualization capacity of students. So that is why many questions will be coming from this chapter. So this is one of the important chapters considering a competitive examination that you are going to write to get the job. Now the problems on time, speed and distance are always favorite to the question setters, because this is very easy topic and this is also a very funny topic to make large number of variety of questions. So the question setters will always have a preference to this chapter. So you will be getting large number of questions from this chapter, and once you understand the theory portions and you do all the practice questions and the example questions by attending to the program keenly, then you will be also able to answer all the questions that can come from this chapter. So this chapter mainly includes relative speed, average speed, races, circular tracks, and then there is application of variation. So we will be doing the discussion with respect to each and every topic one by one. So first we will be moving with the basic concept of time, speed and distance, where time, speed and distance are related together by one single equation, which is a very basic fundamental equation that you would have studied while you were in your school classes. So what is the relation of speed? Speed is equal to distance divided by time. So if you are taking the distance as the displacement, then s is equal to s, or you can, if you are taking s as the variable for speed, then s becomes equal to x divided by t, where x is taken as the distance of travel. So if the distance of travel is x, the time taken is t, and then the speed is equal to s, or s is equal to x divided by t is what is the equation. So this is the basic fundamental equation that you will have to write into your notebook. Now the unit of speed and distance have to be kept same. So if speed has to be converted, we can use meter per second or kilometer per hour. So here we will have to convert kilometer per hour into meter per second, or meter per second into kilometer per hour. So this relationship is also very important. You will have to write it down into your notes. 1 kilometer per hour equals 5 divided by 18 meter per second, or 1 meter per second is equal to 18 divided by 5 kilometer per hour. So these are very basic fundamental relationships. Now calculating average speed. What is average speed? What is actually speed? Actually speed is the simple relationship of distance divided by time. What is speed? Speed is equal to distance divided by time. So what is average speed? Average speed is nothing but it is total distance divided by total time. Very important. Okay. So it is total distance divided by total time is what is average speed. So average speed is equal to total distance divided by total time. Now for calculating the average speed, the first thing that have to be wiped out from the mind is that the average speed is not the average value of different speeds. Normally when you are taking average of the heights, then you will be summing up all the heights and then you will be dividing it with the number. So then you will be getting the average height. But this is not the concept with respect to average speed. So you are not summing up all the speeds and taking the average of the speed, but it is actually the ratio of total distance traveled and the total time taken to cover that distance. So what is average speed? Average speed is total distance divided by total time. So this is the next concept, and you will have to put this equation in the box. Now we will just start with doing some example questions. The first example question is that a car is covering first 400 meters with the speed 72 km per hour and the next 300 meters with the speed 36 km per hour. So find out the average speed of the car. So what is average speed? Average speed is equal to total distance divided by total time. And you can see what is the total distance. Total distance is equal to 400 plus 300, which will come to 700 meters. Okay. And now we will have to find out the total time. So you will have to find out a time for the first journey of 400 meters, and then we will also have to find out the time for the next journey of 300 meters. So the time taken to cover the first 400 equals 400 divided by, because it is 72 km per hour, you will have to convert it into meter per second. So 72 km per hour into 5 divided by 18, which will give you 20 seconds. Okay. So 20 seconds is the time taken to cover the first set of distance of 400 meters, and then the time taken to cover the next 300 meters is 300 divided by 36 into 5 by 18, or it becomes equal to 30 seconds. So what is total time? Total time is 20 seconds plus 30 seconds, which will come to 50 seconds. So what is average speed? Average speed is total distance divided by total time. What is total distance? It is 700 meters. What is total time? It is 50 seconds. So what is average speed? Average speed is 700 divided by 50, or it comes to 14 meter per second. Now moving into the next example, a train covers a distance with a speed 90 km per hour and then double of the previous distance with the speed 60 km per hour. So let us assume that the first distance is d and then the second distance is 2d, because double of the previous distance is the second. So the first distance it covers at 90 km per hour, and the second distance, which is double of the first distance, or 2d, it covers at 60 km per hour. Now find out the average speed is what is the question. So the total distance is what? Total distance is d plus 2d, which will come to 3d. And then we will have to find out the time taken. Time taken means for the first case it is d divided by 90. For the second case it is 2d divided by 60, or it becomes d divided by 30. Total distance is d plus 2d, which is equal to 3d. So what is average speed? Average speed is equal to total distance divided by time taken, and time taken is equal to d divided by 90 plus d divided by 30. So when you are simplifying this expression and cancelling d, you will get it as 270 divided by 4, or 67.5 kilometers per hour. So what is our average speed? Our average speed is 67.5 kilometers per hour. Now we are moving into the next concept of relative of time, speed and distance, and the next concept is called relative speed. Now relative speed is very good application part of time, speed and distance. Relative speed is defined as the speed of one moving body with respect to another moving body. So that is what is the significance. So when you are having problems with moving bodies, relative speed is going to play a major role. So if two bodies are running with the speed of A and B, then the relative speed of one body when they are moving on the same plane. Okay, so we are going to make expressions for the same. So that means first body is running with a speed of A and the second body is running with a speed of B, and if they are moving in the same direction, then their relative speed will be A minus B. So you have to put these expressions in your answer note. For every condition you must be having the equation. So if they are moving in the same direction, then the relative speed is A minus B. If they are moving in the opposite directions, then the relative speed is A plus B. Okay. If they are moving as one on another, for example, as a man moving on an escalator, then if it is in the same direction, then the relative speed is equal to A plus B, and if it is in the opposite direction, then the relative speed is equal to A minus B. Very important. Very important. So very important expression. If there are two bodies, the first body is running with a speed A and the second body is running with the speed b, and if both bodies are moving on a plane, then the relative speed will be a minus b if they are moving in the same direction, and a plus b if they are moving in the opposite direction. Then if one body is moving on another body, so that means a man, example, a man standing on an elevator, so that means a man is already moving on the elevator. Then if it is in the same direction, then the relative velocity is equal to a plus b, and for opposite direction the relative velocity is equal to a minus b. So that is what is our expressions for the relative speed. So all these expressions you have to put down in your notebook. These expressions are extremely useful with respect to the various conditions that can come for our questions. So when a question is coming, you will have to check out the condition and you have to apply the equation which is applicable for the condition. So continuing our discussion with the next theory topic. The next theory topic is actually problems on trains. So in many competitive examinations, you will have questions coming with respect to trains. So that means a train is a common example for making you do questions on relative velocity and relative speed. So in these kinds of questions, when a train crosses any body, it has to cover its own length apart from the length of the object. So you can see if a train is crossing another object, if the train is equal to AB and other object is equal to CD, you can see if the train is to cross, if the train AB is to cross the object CD, it has to cover the total distance of AB plus CD, AB plus CD, because it has to cover its own length and also the length of CD. So that is what is said here. If the train has to cross any body, then it has to cover its own length apart from the length of the other object. So that means the train will have to cover the length of the first object L1 and then the second object L2. So if the train is of length L1 and the object that is to be covered is of length L2, then the total distance it takes will be L1 plus L2. Okay. So the relative distance will be the sum of the length of the train and the length of the object. Now if LT is the length of the train, L0 is the length of the object, UT is the speed of the train, and U0 is the speed of the object. So you have to put down these variables as LT as length of the train, L0 as the length of the object, UT as the velocity or the speed of the train, and then U0 as the speed of the object. Then the time taken for the crossing. The time taken for the crossing will be given by T is equal to LT plus L0 divided by UT plus or minus U0. So what is time T? Time T is equal to LT plus L0 divided by UT plus or minus U0. So for the same direction, we will take a negative sign, while for opposite direction, we will be taking the positive sign. So for same direction, we will be taking the negative sign, and for the opposite direction we will be taking the positive sign. So what is the total time taken for the crossing? The total time taken for the crossing will be LT plus L0 divided by UT plus or minus U0. So for same direction you have to take the denominator as the negative sign, and if it is in the opposite direction then you have to take the denominator with the positive sign. Now rivers and boats. So similar to trains, this is also a very favorite area for the question setters. So the questions can come with respect to rivers and boats. Now for the case of boats and river, the condition is similar as that of the train problems. Only thing or the only difference, so in the case of rivers and boats, the condition and the way that we are doing the question is very similar to that of the train problems. We will be doing the questions in the similar fashion of that of the train problems, but the only thing that you have to understand is upstream means movement against the river flow, and downstream means moving along the river flow. So moving in the same direction of river is what is called downstream, and moving against the direction of the river is what is called upstream. Okay, so if u0 is the speed of the object and ut is the speed of the river, or ur, we will be taking ur for convenience because ut is taken for train. So you can see, if u0 is the speed of the object and ur is the speed of the river, then for upstream, relative speed is equal to u0 minus ur, because it will be opposite, because the flow of river is against the movement of the object. So that means the relative speed is equal to u0 minus ur. But when you are moving downstream, then the relative speed is equal to u0 plus ur, because you are moving along the direction of the river. So even if you are not doing anything, you will be moving along with the river. So the net relative speed will be u0 plus ur if we are moving downstream, and if we are moving upstream against the direction of the river, then it will be u0 minus ur, which is the relative velocity. So that is the case with the rivers and boats. Now we will just check out an example question to demonstrate the theory that we have already studied. So a person covers a distance downstream in 3 hours while returns back in 9 hours. So that means when he is going downstream, it takes 3 hours for him. But when he is returning, so that means when he is moving upstream, it is taking 9 hours. If the speed of the river is 10 meter per second, you have to find out the speed of man. So that means ur is given, we don't know the value of u0. So value of u0 is to be found out. So what will be our upstream speed? Upstream speed is equal to u0 minus 10, and the downstream speed is equal to u0 plus 10. Okay, so the distance covered are the same because he is traveling the same distance along the river. So that means you can write it as u0 minus 10 into 9, okay, equals u0 plus 10 into 3. So from this you will have to find out the value of u0, and u0 will come to be 20 meter per second. Okay, so for doing these mathematics, you will have to pause the video, and then you have to take down all the values from the question, and then you will have to work it out and take the answer and verify with respect to the answer that I will be teaching you in the class. So it will take a lot of time for you to study these videos, because you will have to pause the videos in between and do the problems by yourself. So you must have a great commitment towards your future. You are following the classes very strictly, very tightly, neatly, doing all these questions, the example questions, the practice questions, and also all the previous questions, and then the test papers systematically with the discipline and with commitment, particularly commitment towards what you are doing. You will be able to clear all these examinations and you will be able to get into the job as soon as possible. Okay, so you have to prepare for say next 6 months or 1 year, such that you are definitely going to get into a great job. Okay, now moving into the next question, the next example question. A train increases its speed by 20% and reaches 7 minutes early. So you can see these kinds of questions are really good questions. When this kind of a question is coming for your examination, most of your friends will not be able to answer for this question. So a train increases its speed by 20%. So if the train is increasing its speed by 20%, that means it becomes 120 out of 100. Okay, it is increasing its speed by 20%. So it goes beyond the 100% of what was previously. So that means it becomes equal to 120 divided by 100 times, or it becomes equal to 6 divided by 5 times of the original speed, and it reaches 7 minutes early. Okay, so if the initial time was t, the new time will be 5 divided by 60, because the time is inversely proportional. Okay, because what is speed? Speed is equal to distance divided by time. So that means time is inversely proportional to speed. As time increases, speed decreases. As time decreases, speed increases. So that means you will have to take it as 5 by 6 times of t. And then it reaches 7 minutes early. So that means if it was reaching normally by t minutes, Now it is reaching t minus 5 by 6t. So that means it is equal to 7. So it is t minus 5 by 6t becomes equal to 7, or from this we will be able to find out the value of t. So that means t is equal to 42 minutes. So the original time that it takes to reach the destination is equal to t, and it is equal to 42 minutes. So this is the answer for this example question. Continuing with our example questions, the next question is, two trains start from different stations towards each other at the same time and meets at point P. From point P, both the trains take 4 hours and 9 hours to reach their destination. Find out the ratio of their speeds is what is the question. So two trains are starting from each other, from two different ends and moving towards each other. Let us take it as A and B. They are meeting each other at the same time and it meets at point P. So the trains are meeting at point P. So that the hours that they have travelled, let us assume that A has travelled t hours and B also have travelled t hours, and they are reaching at point P. And from point P, both the trains take 4 hours and 9 hours to reach their destination. Find out the ratio of their speeds is what is the question. So these kinds of questions a normal candidate will not be able to do. So that is the importance of taking the training program. So once you take the training program, these kinds of questions are differentiating questions. Once you do these kinds of questions, definitely you will be getting the job. Now, ratio of their speeds, I have already told you that the ratio of the speeds is actually inversely proportional to the ratio of the times. So let us consider the ratio of the speeds. With respect to the first distance AP, it is actually t divided by 9. So when it is 1 divided by ratio of times, it becomes A by B equals t 1 divided by t by 9, which becomes equal to 9 divided by t. And then for the second case, it is actually 4 divided by t, or it is equal to 1 by 4 by t, which is equal to t divided by 4. And since the time are equal, the distances are equal, we will be able to equate the equation 1 and equation 2. So that means 9 by t is equal to t divided by 4, from which you will be obtaining t is equal to 6. And when t is equal to 6, you are substituting t is equal to 6 into this. So A by B becomes equal to 9 divided by 6, or it becomes equal to 3 by 2. So that is answer for this question. So 4 hours to reach their destination, find out the ratio of their speeds. What is the ratio of their speeds? The ratio of their speeds is equal to A by B, which is equal to 9 divided by 6, or equal to 3 by 2. So that is what is this example is. Now moving into the next example question. Two trains start from Delhi and Mumbai towards each other at 10 a.m. in the morning, and they reaches their destination on the same day at 4 p.m. and 8 p.m. respectively. Find out at what time they crosses each other. So their crossing time is to be found out. So two trains are starting from Delhi and Mumbai. So that means one train is starting from Delhi at 10 a.m. in the morning. Then the other train is starting from Mumbai at 10 a.m. in the morning. Both of them are moving towards each other. And this train reaches 4 p.m. at Mumbai, and this train is reaching at 8 p.m. at Delhi. So we will have to find out that time, what time they are crossing each other. So the time taken by the Delhi train from 10 a.m. to 4 p.m. is equal to 6 hours, and the time taken by the Mumbai train to reach Delhi is actually 10 hours. Okay. So the speed ratio is actually 10 divided by 6, because it is the inverse variation. So it is d divided by m is equal to 10 divided by 6, which is in the inverse ratio. Now let the speed of d is equal to 5 times k, because when you are going to cancel this, this becomes equal to 5 divided by 3. So it is a factor of 5 and 3. So let us assume that it is 5k and 3k. And distance between Delhi and Mumbai is actually 5k, because the first train is taking 6 hours and the second train is taking 10 hours. So it is 5k into 6, which contributes 30k. and then it is 10 into 3k, which will also contribute to 30k. So what is the distance between Delhi and Mumbai? Distance between Delhi and Mumbai is 30k units. So now the problem is, two trains are at a distance 30k apart, running towards each other. Okay. So the time taken to meet, so their velocities are 5k and 3k. Since they are moving against each other, their total relative velocity will be 5k plus 3k. And what is the total distance? The total distance is equal to 30k. So it is 30k divided by 5k plus 3k, or it is equal to 15 divided by 4 hours. 15 divided by 4 hours means it is 3 hours 45 minutes. So they are starting at 10 a.m. So that means it is after 10 a.m. 3 hours has to go. So that means 11, 12, 1 and then another 45 minutes. So they are crossing each other at 1:45 p.m. So this is what is the answer to this good question. So this is a very, very good question. Most of the students will not be doing this question, but you have to practice this. Like when nobody else is doing, we will have to definitely do this question to get the job. So now the next theory portion is races. So you can see that in Olympics and all, races are going on around a stadium. So in races, there are two sorts of comparisons which can generally be carried out. So there can be comparison of distance and speed. There can be comparison of speed with respect to time. Okay. So normally in a 100-meter race, you can see the distance is compared with respect to the speed and time. So the distance is fixed to be the 100 meters or the 400 meters or the 1500 meters, and then the time that is taken by the person to cover the distance will be noted, and then the awards will be given for a competition. So this is the relation of races with respect to distance and speed, and also with respect to speed and time. So let us check out a simple problem with respect to races. Here you can see this is a 100-meter race. A beats B by 20 meters and B beats C by 20 meters. So find out by what distance A is beating C is what is the question. So there is a 100-meter race. A becomes the winner and A beats B by 20 meters. And B is the second achiever or the silver medalist, and B beats C by 20 meters. Find out what distance A beats C is what is the question. So you can see A is beating B by 20 meters. So that means when A is covering 100 meters, B only covers 80 meters. Because there is a difference of 20 meters. Because it is already given that A beats B by 20 meters. So that means what is the ratio of their speeds? It is 10:8, or it is actually 5:4, because 10:8 is equal to 5:4. Similarly, B also beats C by 20 meters. So that means the ratio of speeds between B and C is also equal to 5:4. Okay. So now you will have to find out the relationship with respect to A and C, because A is to B is equal to 5:4. And B is to C is equal to 5:4. So if you want to find out the ratios between A and C, then you will have to equate this value. You will have to equate this value, because the ratio value of B has to be equated. So if you want to equate this value, you can convert 4 to 20. You can convert 4 to 20 by multiplying this ratio with 5. So that means this ratio becomes equal to 25:20. Okay. And to convert 5 to 20, you will have to multiply this ratio with 4. So that means this becomes equal to 20:16. So this is A, this is B, and this is C. This is C. Okay. So now what is eliminating B? What is the ratio of A to C? The ratio of A to C is 25:16. 25:16. So that means when A is covering 100 meters, A is covering 100 meters means 25 into 4. 25 into 4, A is going to cover 100 meters. Then the distance covered by C will be 16 into 4. So what is 16 into 4? 16 into 4 is equal to 64 meters. So by the time A is going to cover 100 meters, C is going to cover only 64 meters. So by what distance will A beat C? A will beat C at a distance of 100 minus 64. What is 100 minus 64? So A is going to beat C by 36 meters, because 36 meters is the difference between 100 and 64. So A will beat C by 34 meters. So this is also a very good logical question. Normally students will go for 20 meters as the distance between A and C. But you can see the 20 meters is not the distance between A and C. A is going to beat C by a distance of 36 meters. So that is answer to this example question. So now we have discussed all the theory portions and the example questions with respect to the chapter time, speed and distance. Now we are going to move into do the practice questions for this chapter time, speed and distance. Once you do completing all the practice questions, and after completing the practice questions we will be going to do the previous questions asked for various examinations from time, speed and distance. So once you complete all these topics as a sequence, chapter 8 will be completely completed, and then you will be able to answer any questions that are going to come from this chapter. So now we have completed all the theory portions. We are going to move into the practice questions for the chapter time, speed and distance.